think pair share with the student sitting next to you. All right, thank you. Can someone tell me what is an ionic compound? Any volunteers? Yes, Jackson.
A metal and a non-metal.
All right, an ionic compound is a compound which is formed between a metal and a non-metal by... Can somebody continue with the sentence? Yes, Matthew.
Transferring the metal's valence electron to the non-metal?
Thank you. By transferring of electrons. Very good. Now, what about a covalent compound? Yes, Miraj.
So when one metal shares its electrons with another non-metal?
Yes, exactly. Very good. So a covalent compound is a compound which is formed between a metal and a non-metal by sharing electrons. All right. So as you can see here, ionic formulae consist of metals and non-metals, whereas covalent formulae consist of all non-metals. Now, however, there is a similarity when we name the compounds. All right. Both compounds, when you name them, we name the element in order and change the ending of last element to IDE. For example, let's look at KF. Now, K is potassium, F is fluorine. But do remember, you have to change the ending of last element to IDE. Hence, fluorine will become fluoride. So it is potassium fluoride. The same rule applies when you name a covalent compound. But the thing is, you have to remember, we have to add prefixes to show the number of atoms of each element. So for example, NH3. Now, N is nitrogen. H is hydride. All right? But you have to mention the number over here. So you need to add a prefix in front of hydride. So this is a 3 here. So we put trihydride. All right? Now, I would like to give you 2 compounds over here. Can you try to name them, please? Anyone would like to tell me the name of this compound? Yes, Naja. Sodium chloride. Thank you. Very good. Sodium chloride. All right. What about this one? N2O5. Yes, Ibrahim.
Dinitrogen pentoxide.
Very good. So 2 here. So we have to put a prefix in front. So this is dinitrogen 5. So pentoxide. All right. Clear, everyone? Okay, let's go to the next one. Now, let's review on how to write ionic formulae. There are 2 methods in writing ionic formulae. This is the first method we call balancing charges. There are 5 rules in balancing charges. They are as follows. Now, the positive ion is written first, and the negative ion is written second. Next, the total number of each ion is adjusted, so the total positive charge equals the total negative charge. This is very important, all right? Then, subscripts are used to indicate the number of each ion present. Finally, when there is more than 1 polyatomic ion, brackets are needed around the ion. Okay, let's look at this example, calcium hydroxide. All right? The positive ion is written first, so we write down calcium ions. And the negative ion is written second, so we write down hydroxide ions. All right. Next, you can see here, one calcium ions will require two hydroxide ions to balance the charges. Hence, the number 2 here has to be written as a subscript. All right. And do not forget, we need to put a bracket around the polyatomic ion. Hence, calcium hydroxide is Ca bracket OH with a subscript, with the number 2 as a subscript. All right? Now, this is the second method where we call number swap. All right? This is a slightly easier method as it only involves 3 rules. So the first rule is write the name of the compound. 2, write the ions in the compound. And lastly, we swap the numbers and drop them to the bottom. Now let's have a look at aluminium sulfide. All right, aluminium is represented by Al3+. Sulfide is represented by S2 negative. All right, now you need to take the number down, which is given by the ion. So there's 3+ here, so we take down the number 3. There's a 2 negative here, so we take down the number 2. Next thing, you need to swap the numbers. So we swap the numbers and we drop them to the bottom. That's why it becomes Al2S3 as the formula. All right? Any questions so far? No. All right, good. Now, next, let's go to balancing equations. Okay, there are also 2 methods in balancing equations. All right, let's look at the first method, which is the tally method. Now, let's say we have copper reacts with oxygen, produces copper oxide. Copper is represented by Cu, oxygen is represented by O2, copper oxide is represented by CuO. All right, so let me write it down for you once again. So copper plus oxygen produces copper oxide. All right. In order to balance the equation, the number of atoms of that element on the left-hand side of the arrow has to be equal to the number of atoms of that element on the right-hand side of the arrow. So let's check. Here, we have 1 Cu. On the right-hand side, we have 1 Cu as well. So it is balanced. Let's look at oxygen. 1 times 2, you have 2 oxygen atoms on the left-hand side of the arrow. When you look at the right-hand side of the arrow, 1 times 1 equals to 1. So it's only 1 oxygen atom over here. So the oxygen atoms are not balanced. All right? In order for you to balance the equation, I need to put 2 here as the coefficient so that I can balance the number of oxygen atoms. Right? Now, the number of oxygen atoms are balanced. But the thing is, what about the copper atoms? Now they are not balanced. In order to balance them, what do you need to put as the coefficient for copper? Anyone, please? Yes, MK? 2. Very good. Thank you. So when I put 2 here, the copper atoms are also balanced. Right? So this is a balanced chemical equation using the tally method. All right? Now, let's have a look on the Minov method. Now, Minov is an acronym for metals, ions, non-metals, oxygen, and hydrogen. Now, according to this method, you need to balance the metals first, followed by the polyatomic ions. Next, you look for non-metals, which are not involved in a polyatomic ion. And lastly, you balance the oxygen and hydrogen. All right? Now, in order to check for your understanding, I would like everyone to give it a go on balancing the equations on the board. I'll give you a few minutes. All right. Any volunteers to come to the front to balance the equations? Anyone? Come on. Yes, thank you. Anyone else? Yes, hands. Yes, sure. Helen, thank you. Thank you. Yes. So, put down balance. All right, the last equation, please. Yes. Thank you. Let's look at the answers. Well done. Very good. Okay. Any questions from anyone, please? Okay, good. Let's go to the next one. All right. Now, before we wrap up the revision for today,